arithmetic operators. Let's make a working copy of working.cpp from the Chapter 6 folder. We'll paste it here into our working project and open it up. Start out by declaring a couple of integers here, and we're going to just replace this C out with a printf because that's just a little easier for some of these things. And I can put the arithmetic operation right in here. I can say I plus j, and it'll say the result is, and it'll come up with a 47. There it is, 47. So this is just a simple case of integer arithmetic. I'm adding two values and I'm using the addition operator. I could use the subtraction operator and I'll get a negative value. I think this will come out at negative 37 if I'm not mistaken. There we go, negative 37, because I'm subtracting a larger value from a smaller value. We can do multiplication, and I'm not going to try and do this one in my head. Save that and run it, and we get a value of 210. And we can do division, and I'm actually going to do the division in the other way because this will work better for this purpose. So 42 divided by 5. Now, I believe this will give me a value of 8. And the reason for that is that we're working in integer arithmetic. And so it gives me a value of 8, and there's also a remainder, and I can get the remainder with the modulo operator, and that remainder should be 2. So I'll run that, and there the remainder is 2. So those are the 5 basic functions. We have addition, subtraction, multiplication, division, and remainder or modulus. Now, all of these, with the exception of the modulo operator, are also available for floating points. So if I just declare these as floats, and I'll start with an addition, and let's give them a fractional part, 5.1 and 42.2. And so I'll run that, and you notice we get this large integer because I'm interpreting it as an integer. We also have a warning over here that says it expects int, and we got a type of double. Float gets promoted to double when it's used with printf in C++. And so I'm just going to say F there instead, and we'll run it. And we get 47.29999. So we get some nice rounding errors there as well. And that's actually to be expected with float. If we make this double, we have a lower chance of having that happen. And there we go, 47.3000. We can do the same thing with subtraction. And we'll save that and run it, and we get a subtraction result. And multiplication, save it and run it. And we get our 215.22, and division, 8 point blah, blah, blah. And in fact, with the floating point, we can do division, and we can expect to get a reasonable result in the other direction, and we get a fractional part. And of course, the modulo operator does not have any meaning in this case. And so if we try to run that, we get an error that says that the binary operator modulo does not apply for double to double. There are also unary versions of the plus and minus operators. So I'm just going to comment out I here, and we'll just take j. And if I put a unary minus in front of it, we'll get minus 42.2. And if I put a unary plus in front of it, we'll get a positive 42.2, which is the same as what it is by itself. So the unary plus in most contexts is semantically null, and it's very rarely actually used. There is another use of the binary version of the plus operator. And in STL containers, like the string class, if I say string, this is a string, and we'll call that one S1. And if I say string S2 equals, this is another string. So we'll use a cout for this, and I'll say cout S1 is, and we'll do the same thing for S2. And then we will add them together. We'll concatenate them. So call this concatenate. And that's S1 plus S2. So we'll go ahead and save this and run it. And so string 1 is this is a string. String 2 is this is another string. And you see the concatenation. This is a string, and then the second string is jammed right on the end of it there. And that's another use of the plus operator. So this is really an example of an operator overload. And in the case of the STL containers, this is a very, very common usage, which is why I'm covering it here. And for some of your own containers that you might define, you might want to also overload the plus operator. And we'll show you how to do that in the chapter on classes. So the arithmetic operators in C and C++ are simple and effective. They work with all the basic types and can be overloaded for use with C++ classes. We'll cover operator overloading in a later chapter. Now let's delete our working file.